In the Milky Way galaxy, which is our galaxy, there are between 100 to 400 billion stars. Our galaxy, which spans approximately 200,000 light years, is incredibly vast. Around 13.5 billion years ago, star formation began in this galaxy, and gradually, due to gravity, many stars started forming from the merging of gas and dust clouds. Currently, an overwhelming majority of 95% of the stars within our galaxy have already been formed and are approaching the conclusion of their life cycle. We find ourselves in a period of the universe where the emergence of new stars has nearly come to a halt. Within our galaxy, merely 3 new stars are created annually. As a result, the pace of new star formation across every galaxy is exceedingly slow. The universe is now in the preliminary phases of its conclusion. In such a situation, we must traverse swiftly, otherwise we might never have the opportunity to witness numerous phenomena. The second most significant challenge that will perpetually hinder the completion of our journey is the continuous expansion of the universe. Therefore, considering all these factors, how far can we actually venture within this universe? Let us explore. Our Milky Way galaxy and the neighboring Andromeda galaxy are part of a group that includes 5,500 galaxies. These 54 galaxies together form a group known as the local group. There are thousands of such groups that are interconnected. Thousands of groups like the local group are part of a supercluster. Over 100,000 such superclusters together make up the entire observable universe. There are an estimated total of 2 trillion galaxies encompassed within the observable universe. When contemplating the immense scale of this, it becomes unequivocally certain that we can never fully traverse it. We can only endeavor to traverse the portion that is gravitationally bound to us, meaning it is connected to us in some manner by gravity. In such circumstances, we are only capable of exploring up to approximately 6% of the vast observable universe with our human civilization. It's a boundary that, even if we became immortal for billions of years, we can't cross. Even in such circumstances, we are unable to traverse it. Out of the estimated 2 trillion galaxies, we will never have the opportunity to explore approximately 1.8 trillion of them. These galaxies are perpetually beyond our reach. There is absolutely no way to interact with them. So why is that the case? Why are these galaxies so far from us? Let's find out. To understand this, we must go back to the Big Bang. After the Big Bang, in a fraction of a second, specifically 10 to the power of 36 seconds, the matter that was condensed into a single point begins to expand. The matter, initially contained in a small size, has now spread across billions of kilometers, and everything is expanding at an incredibly rapid pace. This is the era of inflation. At this time, all the matter that was condensed in the universe of the Big Bang was expanding. It has expanded so much that in various parts of the universe, clouds of heavier and denser matter have formed, while in other areas, lighter and low-density matter is spread out. Now the regions with heavier matter are influenced by gravity, causing them to start attracting each other, and gradually many galaxies begin to form in this manner. In this region, all the galaxies that form are gravitationally bound to one another and are interconnected by gravitational forces in certain locations. Our Milky Way galaxy and the Andromeda galaxy, together with other galaxies, are held together by gravity within a similar region, which is known as the local group. Anything that exists beyond this group lies outside the influence of our gravitational pull and continues to expand. Analogous to the local group, numerous galaxy clusters are persistently receding from us, rendering it progressively challenging to access them in the foreseeable future. Nevertheless, a more significant concern is our lack of precise knowledge regarding the exact rate at which our universe is expanding and the underlying reasons for this phenomenon. Researchers, however, ascribe this to the influence of dark energy. It is precisely the exact opposite of gravitational forces, separating entities from one another. It is this enigmatic and invisible form of energy that causes the fabric of space to perpetually expand, with its rate of expansion continually accelerating. In a universe that is expanding at a velocity exceeding the speed of light, scientists are of the opinion that a boundary has now been established in this universe, beyond which, if anything ventures, thus, human civilization will never be able to trace or observe it once more. It appears remarkably similar to the event horizon of a black hole, where if something ventures beyond, it does not return. In a similar manner, a cosmic horizon has been established for us, which is persistently contracting. As time progresses, our boundary is diminishing, and galaxies are receding significantly further away from us. Approximately 19.4% of galaxies have crossed this horizon, which means that even if we live for eternity, we will never be able to interact with the civilizations residing in these galaxies.